Hey everybody. So we're not going to have class on Monday because of Labor Day, but I didn't want you to fall behind on the lab. So I'm putting together this video, which will be a partial walkthrough about using some of the tools which you've already seen and you should already know. But they're definitely like it's so easy to get some hiccups along the way that you want to I want to go over it again. And so I'm going to go through a few things here, including what you'll need to do for Lab 2, specifically for our class. But before that, I wanted to talk a little bit about Zulip and that we've been using. And I'm going to be using this for most things for communications. And I do encourage you to use this in general, not just for just the class stuff, but it can be a useful tool in general. And so here I've got it. This is a different Zulip server. It's one that I set up that I'm going to set up for some of the teachers that I work with. But right now nobody's on this, so I could figure I can use this to demo things, and there won't be any privacy issues, and I can just make this publicly available because this is just me here. But it's like we had with Slack, but it's different in that it's got these channels. These are called streams, and then it also has threads within them. So in general, if you're going to do something like you want to, like first you can show all of them here, or you can show an individual, an individual channel, or even an individual stream. And you can hear, like in general, I can look at everything in general, or let's look at swimming turtles. Or I can click here or actually let me X on this. Click, no, that wasn't it. Let me go to all messages. And if I click here, I can just look at unread messages, etc. And you can do various other things as well. So for example, if you have a message, so if we're in general and I want to talk about, I want to look at the swimming turtles, to respond to that, or let's look at everything in general, if I just type down here, what am I going to do? If I want to make a new message which is unrelated to any of our threads in here, I can type new topic, and then this would be a new topic and stuff. And that will go over there. But on the other hand, if I really wanted to respond to this welcome bot message here, I just click on this and notice this is in response to swimming turtles. And like I like turtles. So basically, and there it is. So now we've got the new topic, we've got the swimming turtles, and it keeps everything really, really organized. You might see this periodically. It brings up some help. And so this is related to things like attendance. So like for attendance in class, I'm going to make a new thread each day. And you don't just want to click anywhere. You want to make sure that you click on the thread for the date. And specifically do that. So that's just what I want. Just a very, very quick 3 minutes on Zulip, and we're done with that for now. And now let's talk about. Let me just open up a new terminal. The lab and what you'll need to know. So basically, the couple of things here. The first thing for the lab is remember that whenever you accept the assignment, and this is the last assignment, so you've already accepted that, and I will be posting these on Zulip, and I'll probably post Lab 2 tomorrow, which will be Friday, but certainly I'll post it over the weekend. Basically, you'll accept the link, and then it'll eventually say it's done, and you'll click on what it says, and it'll bring you to the GitHub repo, and you want to click on code, and it should say clone with SSH. If it doesn't say clone with SSH, you're going to want to go back to your settings and make sure you have done your SSH keys. And and there's help on that. I posted, I showed you where I had those videos on how to set up SSH keys, but it's important to do that. So then you can clone this. So I'm going to copy this, go to a terminal, and I'm going to go to my GitHub directory, and you can be in any folder, and I'm going to git clone, and if I just do this, it's going to give me a folder named Fall 2020, make it even bigger, 135 Lab 1, but if I just give it a different name afterwards, we'll say Lab-01, you'll see I now have a directory Lab-01. And I'm doing this under Linux, but if you're doing this on a Mac, if you open a Mac terminal, it should be exactly the same. If you're doing it under Linux, it obviously is the same. If you're doing it under Windows, if you're using the bash shell, it should be the same. But your directories are going to be a little bit different. And if you're doing it under the Linux subsystem, it should be pretty much this way. It might be a little different if you just use the command terminal. So, use Zulip and use the TAs for help for that. So I'm going to go into Lab 1, and this is where I will actually work. So we're not going to really do the lab because I haven't released it yet. But in general, you're going to want to create files for this. So one of the files, so let's say we're going to, the lab says make something called program.cpp. So for program.cpp, I'm going to edit. It's going to be in my GitHub directory, lab01, and it's going to be program.cpp, and I can start writing my program. And that's that, and we can do and now I can test it, and it all works. Now notice though that this is notice that I have to be in the directory that I've cloned from GitHub. But now I can do git add program.cpp and actually git commit program.cpp, and I added a program, and then git push. And then we see here, if we reload, we've got program. And if I make a change, like hello, hello, test it, and then I can do git commit, added a second hello. I need the -m here. And every time I make a change, I only have to add it once, but every time I make a change, I can commit and push it. If I want to get rid of it, I could do a git rm program.cpp, but I'm not going to do that. And then I have to push. I'd have to remove, commit, and actually I will do it. So I'm going to kill the buffer here. I did that, and notice I removed it, but it's still up there. But if I look here, it's not here. This is the backup file. If I commit it, reload the page, it's still up here. But then when I do a git push, now it's removed. Now we can still get back to it. There's a way to do that, but that's effectively if you add stuff by mistake. So let's go to another program, and that's so gh lab01, and we'll call this out main.cpp, and one of the things that you are going to have to do for the next lab are use functions. And a function, which you probably know, it's similar in C++ as it is in Java. Java, basically a Java method. So in Java, you would have in a class, you'd have like public or private. We don't have that here yet. And then you'll have like a return type, int, or void if it doesn't return. So you all know this from your APCSA classes. So you can say like int some function, let's say add 2, int a and int b. And we'll just return a plus b. And we'll say here int c equals add 2 of 5 and 10. And then we will see out c. Let's compile it. And it works. Okay, nothing earth-shattering here. As is my practice, I will add main.cpp. Just to get it into version control. Now, you can write functions, and again, it's like Java in that you've got the, these could be int, double, etc. The return type can be void, int, double, string, and there are all sorts of nuances. Like there are different nuances, particularly when we get to references in C++ versus what you already know from Java, but the basics are pretty much the same. Now, one thing though that comes up is, what if you're writing your program and you like to write it like this? So now I just move my function underneath. So now if I compile this, notice it says, oh no, add2 was not declared in this scope. It can't tell that it's there. And the reason for that is because the compiler goes from the top to the bottom. So it basically starts here and it works its way down, and it gets to here and says add2. What's add2? I don't know, because it won't know about add2 until over here. Now, yeah, I know a compiler should be able to figure this out, except there are reasons why, historic reasons. Compilers used to be much slower, and it was hard to figure that out. It'd have to pass through your data multiple times. And so a solution was developed, something called prototyping. And so you'd give a function a prototype if you needed it before you declare it. And most like C programmers I know don't program in this way. They'll usually put the functions they need above. But if you get to the situation, you need a function prototype or specification, which is basically the return type, the name of the function, and then the parameters. So notice it's the same as this, but without A and B, it doesn't need those, and with a semicolon. So what this is saying, this says, hey, we're going to declare add2 later. Trust me. And so now it's saying, hey, trust me. And so we get to here and we say, oh, we need add2. We got 2 ints and it returns an int. Oh, we know it's going to come up. We trust you. And then eventually it has to resolve. So if we now compile this, we're all good. Now, if we don't ever write the code, it's not going to work. But as long as we've got it there, we're all good. So this is how we handle those forward references in C++, if we're going to have a function that we need later on. Now, usually when I write these, I put these in because what I normally do is I normally just, I'll basically, not that much. I'll usually cut, and paste this and then do that, and that gives me the prototype. That's just the way I like doing it. But anyway, that's how you do things. So that's how you write functions, and also, how you can do this forward referencing. All right, so we're not actually going to work with that right now. What we're going to talk about is something else. I'm going to get rid of these lines here. And we're going to talk about the idea that most programs are big. All right, right now you're writing very small programs at the beginning of the semester, but most programs get pretty big, and so you don't want to contain them all within one file. Now in APCSA, you know that traditionally in Java, you have one file per class. All right, and usually your programs have multiple classes. So, C is similar in that as your program grows, you want to have multiple files. So, and usually you'll contain things. In C++, you'll contain things, you'll put all your math functions together and your graphics functions together, etc. And later on, when you do classes, you'll also learn how classes work in multiple files. But what we're going to do is we're going to put that add2 function into another file. And so we're going to put that into something called funcs.cpp, and that's just going to have add2 in it. Now, if I try to compile g++ main, it says it's missing add2. If I type g++ add2, I have to save this actually, or funcs. It says it doesn't have a main. So I have to have a way of putting these things together, and there are a few steps for that, okay? So the first thing you have to know is when you compile your program, it doesn't just compile it to make a.out. What it actually does is it actually takes your main program and it runs it through a compiler to make an object file. This is just like a compiled file program, but it's got to be reorganized with some extra operating system to run. And so this is what, this is what the compiler does. Basically. And this is what the linker does. And what we can actually do is we can separate these steps. So if you type here, you'll say, if I type G++, let's go back to, let me get rid of those guys. Let's look at smaller.cpp again. So smaller.cpp is just a self-contained program. I can type G++ smaller.cpp and I get a.out. But I can also type G++-c smaller.cpp, and notice what that creates. It creates smaller.o. It makes the object file. Now, if you just compile a self-contained program, it does it all automatically. But here, it creates this object file, and then I can say, take the object file, and that'll, well, let me remove a.out. I can compile the object file, and that makes a.out. So basically, you can do these in steps. So for example, I've got my file add funcs with my functions in it, or my function, and I can type in G++-c, meaning only compile it, don't try to link it. And that worked. And now I have funcs.o. But on the other hand, if I do that with main, it says, I don't know what add2 is. It's the same problem as before with those forward references. So I have to say here, hey, you want to use add2, trust me, add2 is coming. All right, add2 is going to be there. Don't worry about it. So now if I type G++ funcs.cpp, well, G++-c funcs.cpp, that compiles because that takes it from CPP to O. And if I do G++-c main.cpp, that compiles, taking main.cpp to main.o, but I now have to put them together, so I can type in G++ main.o and funcs.o, and it all works. And I can, if I want, main.cpp funcs.cpp. And that works. So that's basically all you have to do. Now you don't want to do this, compile them all together, because we also have that smaller thing over here, and that's an issue. So I'm just going to quickly do a git add of main.cpp and funcs.cpp. And this -a means commit all the changes that are pending. And again, this is a good habit to be in, is just frequently committing. And you don't have to push as much, but I like doing it, but certainly at least committing. So anyway, now we're getting closer. And if we've got another, we've got another thing here, like let's say we're in funcs, and we also have, let's say, int add3, int a, int, and let's just put this up here. And we're going to say, we're going to return add2 of A and B and C. So it's going to add 3 numbers, but those first 2. So now, if I type G++-c funcs.cpp, well, now there's a problem because add2 needs to know, add3 needs to know about add2. Now we could do this, that compiled, or we could put the header, the prototype, and put it up there. And either way works. And we'll talk about the right way in a second. But the problem here is now if we go to main, and we also want to see out, let's see, do C again. And in this case, we're going to say C equals add3 of 5, 10, 15. Now, if we g++ main.cpp and funcs.cpp, now add3 was not declared in main, and notice that it's suggesting some other stuff, but now we can see that we actually need to put this prototype in as well. And now everything works. And the issue here is we're going to need to, like every time we add a function or change a function, we're going to have to get this kind of synced up everywhere. So in C and in C++, they decided to solve this problem, and I'm going to move add3 to the bottom just because I prefer it there, is they wanted to solve this problem, and so they use a concept called header files. And header files are what we're including in here. And the way it works is if we have something called funcs.cpp that also makes, that declares functions that other people are going to use, we're going to make another file called funcs.h, and in it, we're going to put the declarations for the functions that we want to make available. And we also put this at the top, pragma once. You just need it up there. It's just so that if you include things multiple times, it can kind of get wonky. And basically, I'll explain it more when we have a live class, but for now, just put that there. But then what we do is we basically, at the top of funcs.cpp, we include funcs.h. And what this does is it kind of like cuts and pastes the content of funcs.h. It's kind of like it's going to take these two lines of code and literally put them in here. And what we also do is in main, we also include funcs.h. And again, that's like putting those two lines in there, literally putting those in there. It literally expands to be the contents of the file. And so now that we have that, now we can just do g++ funcs main.cpp, funcs.cpp. It doesn't quite all work. We've got a problem, probably because in funcs.h, I didn't put add3 correctly. It's int, int, int. And now everything works. So I'm going to git add funcs.h. And actually, I'm going to make some changes here. So in a comment, and the C++ file should contain all the code, all the program stuff, all the functions. And the .h file should only consist of the declarations, the prototypes. And we're going to modify this later on, but this is the general rule of thumb. And so I'm going to git commit. I'll just put all the changes there. And we'll make sure everything is up here. HTTP. And so for lab 2, parts of lab 2 you're just going to do the normal way, and it'll say when I release the lab. But also in lab 2, there's at least one of your tasks where you're going to have to do it as 2 separate files, which really means 3. You're going to have the main file with main in it, and another file with 1 or more functions in it, and also its matching.h file. So just in here, let me just move that and a.out. Just in here, just having, so the CPP file, which has the actual functions, the H file, which has the declarations, just those prototypes, and main that includes and also uses all of them. All right, so that's the information you're going to need for Lab 2. If you have any questions, hit us up on the Zulip. We have the office hours, and that's pretty much it. I will release Lab 2 probably tomorrow, or if not, sometimes over the weekend. It'll be in the Slack. I'll tag on the Slack in the Zulip. I will tag everybody, and the due date will be a week from tomorrow, a week from Friday, as usual. And I'll see all of you online, and I guess a week from Monday is our next live class. Okay, so that's it. Take it easy.